First of all, yes, thank you very much for BCS, and thank you very much for coming this evening. Hopefully, what I convey to you will have some value in trying to get you further in the career path of data science. Just as a starter, I'm just interested to understand the audience. How many of you on a daily basis use tools such as R? Just put your hand up so I know. Or Python, and SQL, and then if I go to the, okay, that's fine. So I've got a kind of good idea of where they're going with this. So hopefully this will appeal to you as an up-and-coming data scientist audience. Where I've come from, how I'd like to do what I'm doing. I currently run my own business, but I'll take you back to what I started from. So that's how I came into data science, principally as a developer. I left the army, got a BSc, became a developer, worked for some banks in Switzerland. Then after that became a consultant back in London, and then joined the operational side of a very large American bank. That obviously was not data science. I was going back into the world of business, and I just thought, no, I actually do want to stay with computing, and therefore I then set up a business on my own, which was to do raising funds that would then raising funds in Europe for tech ventures in America, which was an interesting idea. And then I set up my own business to try and say, well, I actually want to do something technological myself. I want to raise money for myself, and that's when I started Rosslyn, which listed a few years ago. And the key thing about that is that I've been able to see all different aspects of what makes data science work. In other words, I've been a developer. I've sat there with the headphones on, banging my head against the wall, why does this line of code not work for hours? And suddenly realised it was me. I've been a consultant, so I understand how to understand concepts, ideas, and also run a business, so I know what matters to my bottom line, and of course to my clients. So, what is a data scientist? A lot of people think of data science. When I tell my children I do data science, they just straight away think I'm a nerd who shouldn't be spoken to when they're young. So really, a data scientist is not your best developer. It's not going to be the guy who was the best C# coder and converted to Python, and he just knows everything there is to know, and he's therefore going to be your best data scientist. Don't confuse data science, data engineering, and software engineering. They are very different aspects and they need different skills, but they're all related, they all work together, but that's not, in my view, what a data scientist is. So, the purpose or the meaning of data science is a kind of very encompassing, very broad statement, which is anything to do with the collecting, the analysing, and the modelling. And the key thing is here is it's not so much those tasks, it's what you do with it. Once you've collected the data, you've analysed the data, you've understood the data, you've looked at the data, what are you doing with it? What's the purpose of what you just did? And this came over the last few years, has become more and more important as people have realised, and there's a few very well-known quotes, data is in your will, your data is one of the key assets of your business. People understand there is value there. There is value there because they've also been told, they've gone to presentations, they've been told by some very famous, wise people about what the misuse of data or the lack of using of data will do for your business. The understanding that any of your views without not being backed by data is purely an opinion is quite a strong statement. It means when you go to a board and someone says, I've decided to do this because that's the way he felt that morning and that was his idea. If it's not backed by data, it is purely a stab in the dark based on experience, and it may or may not work. And if he's the boss, it doesn't really matter because he's the boss. If it isn't the boss, if you're not the boss and you make those mistakes, they can be quite fundamental to your career. So do understand the importance of making every decision a fact-based decision. There's also Peter Drucker, who famously said, which is a little bit blunt, but it does work, is that if you basically can't measure it, you can't manage it. Anybody who's got metrics, KPIs, even your annual review for sales numbers, sales targets, whatever they may be, you have to be able to measure something in order to manage it. Else, again, you're guessing. So those concepts of the need to actually understand and quantify what your decision is based on have meant that companies have now realized the importance of digging into their own assets and understanding how to do their strategy, their objectives based on that data that's lying behind them. Very, very big slide, I won't worry too much about that. This is just basically the journey. I'm not so much interested in what happened pre-war, post-war. What I'm interested in is really what's happened since the 90s. Data science has come to be since the 90s. It was computer science and data mining, a chap by the name of Cleveland and others joined the words together and created data science. In 2000, we were able to get a lot more improved technologies to do data mining and to harness data in various ways. And then, obviously, in 2010, we've got Microsoft, Amazon, Google, and others. They're giving us services, giving us data storage in the cloud, meaning we can store this vast amount of data easily, or in a much easier way than we used to. We used to have data centers, we used to manage our own kit, we used to break, we used to have a team of infrastructure experts and network experts. It was painful, it was costly. We've now released of that problem, and now recently, obviously, open source tools, but really the key thing which is important is the availability now on a large scale of AI and ML tools, and also, obviously, large-scale databases, which you can simply rent by the hour, the minute, the second, depending on who you're using. And that is a key difference that we haven't had in the past, that we now have today, which makes the business of a data scientist far more interesting and far more impactful to the business community and the company he works for. Again, just a little bit of noise about big numbers, petabytes, exabytes, zettabytes, whatever. I'm not worried about that too much. I'm just saying this slide is here to say there is more and more data coming to us. There is going to be more and more need for data scientists who understand the meaning of that data, who can talk to data, who can articulate with data, and not just understand that I get 500 million tweets or I get 5 billion searches. Those are great numbers, they're interesting. That's what happens every day, and we're all going to be impacted by this deluge of data. The point is, we need to take a step back and understand that we have, every data scientist works for a company, every company's got a bottom line, every company has objectives, has shareholders, stakeholders. We need to be able to make an impact in that business. We need to be able to show them the benefit of their data. They're not going to do it by themselves. They need us to be able to do that. And therefore, some of the tools we have, and I mentioned AI and ML, this was from a lecture by one of the IBM Watson senior partners there, who was showing us where AI is today. I've had conversations even this morning, which is coincidental, with a client, one of the largest manufacturers in the world, asking me for AI. That was it. He said, I've got data, I want to do AI on my data. And when we said, right, what do you want actually done with that data so I can use AI to help you reach your objective? There's a kind of assumption that if you can talk to Alexa, that will convey straight away to any application I write, and therefore I can ask for things on Alexa, therefore I can ask them to my computer, to my program, I can ask them to my business, this AI thing is simply going to answer any question I want, which I understand fully is feasible, technically feasible, but it needs to be bounded within a context, and understanding that context, again, I'll go back to this over and over again, understanding the context of the question, understanding how to structure the question, understanding how to solve the question is going to be key to a data scientist progressing, but also making an impact within the business. Just being the best Python developer, being the most competent C# or SQL genius is great, but that's what you are. You are the most competent SQL person. You are the best database engineer the company's got. If you do not understand the periphery of what you're dealing with, you're wasting your time and your skills in developing certain content. As far as a data scientist, you're wasting your time. As far as a database developer, you're fantastic. So again, just a last slide on generality before I get into the kind of depths of it. You've all seen the Gartner hype cycle. So this is what happens to every single new emerging product that comes out. And we've all got, next door we've got quantum computing. So we all heard initially quantum computing is about to come in. The world of computing is going to change. It's only going to be a few years away. We're all going to be having quantum laptops, and that VLOOKUP in Excel is going to take 0.02 of a second, and then you're not going to have to go and make a coffee while you just press that go button. So all those kind of things, that as a technology trigger, then you get the peak of expectations, then you get the reality kicks in. What can it do? AI is in a very similar place at the moment. AI, it was going to do everything. I've seen Robocop, and I've seen iRobot, and I've seen all those films, and that's what I'm expecting in the next 3 to 5 years. It's not going to happen in the next 3 to 5 years. Computers are still, even large databases, lexicons, are still trying to understand the meaning of some very fundamental grammatical concepts. They don't get it. We get it instantaneously, they don't get it. They're not going to get it for quite a while. What they are going to do is very quickly be able to associate information with target data sources, training data sets. They are going to be able to separate and cluster very, very swiftly. They are going to be able to use fuzzy logic to associate, make associations you can never make. They are very, very valuable tools, but we just need to make sure that we understand exactly where they are in reality. Now, some of these here are relevant to us. There are general intelligence, there's augmented reality, there's quantum computing, as I mentioned. Those are all big, both hardware, but also software, and also data. What is the purpose of these things? No one's building these things for the fun of them. No one's sat there, with maybe a few guys in white coats going, I've got a really good idea and I'm about to build this thing. They're being built, they're being given money because they're valuable. They're valuable because someone can use the hardware, use the software, but most importantly, use the data that is going to be fed into these technologies to deliver value to a business. If you can articulate to the business what it is you're doing with their technology in order to add value to the bottom line, you will be put on a pedestal very quickly as someone of value to that business. If you are the guy who knows how to turn on all the Hadoop clusters better than anybody else, good. You can do that every day, and that's absolutely fine. What is, in a sense, a data science environment? How does it operate? Your software engineers, as I mentioned earlier, will be collecting data. They'll be gathering the information. They'll be making sure the devices, the hardware, the components are there for us to gather the data together in the first place. Otherwise, we don't have a job. Secondly, your data engineers will then move the data, they'll aggregate the data, they'll do some transformation of the data, they'll get it from its sources, from its swamps, from its lakes, from the repository it lies in, from social media, and move it into a location you can start to harness that data. You will then be able to, still with the data engineers, start doing some general cleaning, some DGP, some valuable work that will mean the quality of that data. Get rid of the noise, basically. Because initially all you've got is a lot of noise, and you've got a bit like you're mining, you're trying to find the nuggets which are going to be of value later on. Now, you come into play at this point here. The data has been prepared in such a way that you can now look at it and you can understand its importance to the business, to the matter at hand. Because what you'll always be doing, you'll always be given a task, an objective, a purpose, and told to go and look at the data and find the answer to this question. Very rarely will you be told to just randomly go and look and see if you can find something, come back in a month's time, and good luck. It will always be for a purpose. So you need to understand the data at its collection point and also the data as it is presented to you now. You then have your experimentation. This is when you've seen the data, you understand how the data has arrived to you, you understand what's been kept, what's been removed, equally important, and you now start experimenting. You start looking at different aspects of that data. Does this solution work better? Do some trials, do some ideas, take some information in one place, talk to other people, and try and work out which is the most useful approach to this data. And you've also always got the guys who are going to spend their life doing the most sophisticated and complicated tasks with that data as well. I mean, I've hired in my firm, I've had PhDs in data mining, algorithm optimization, which I had no idea what that ever was, but he was a great guy and worked very well and did some wonderful work. But there are some people out there who specialize in that top layer, who can really, really add value to the business. Again, they're resources for the data scientist. So what I'm saying is that we're focusing on this area. Again, if you are, depending on where you are in your company, in your career, you may be working for a team of 5, a small startup. As the data scientist, resident data scientist, you'll be doing all those things. You'll be going collecting the data. You'll be using anything from Sage system to Excel to social media to unstructured data, structured data, whatever it may be. You'll be the go-to man for anything with the data in front of it. Most companies of a medium size will have that broken down into software engineers, data engineers, and then data scientists, and they may also do the top data to a certain extent. But really, the impact you make on the business is going to be done at those 2 levels there. Those are the ones where you understand the data, you've applied your understanding of the business to that data, and you have then come up with some insights. Initially, some of them may be completely wrong, flawed, mad, nobody would ever do that, and I've got a few cases, a few ideas about those as well. Some consultants came in and mentioned one of the largest logistics company that the best way to save money is to cut that thing over there that seems to be losing money, and that was actually one of the biggest. While he was losing money, it was one of the biggest revenue generators of the business, and there was a massive strategic plan to increase that over time. But as a consultant coming in with no understanding, just looking at the numbers, you may make a totally logical decision and a proposal, which is fundamentally flawed, and everybody looks around at you and thinks you're a complete lunatic, you're actually even commenting on it. So the idea is understanding the question as well as understanding how you got to the answer. So this is one of my normal slides, and I've been using this for years, so I apologize if it's a bit old, but it works for me. In a sense, what you have here is you have there the data swamp, which is the repository of all data. So the places I work in, the companies I work for, it's mainly structured data, it's financial data, transactional data, it's accounts payable, accounts receivable, it's finance. We also, a couple of years ago, bought a company that specializes in unstructured data. That's been a big eye-opener, joining the two together. That's always something which I thought was not really something I get into. Doing it is absolutely fascinating to find a correlation between information in both those sources. Now they go through to the refinery. The refinery is where the data merges together and the business logic gets applied. Now this is not necessarily what you could call the business rules, it's more the business logic, which is what the client tells you, what you know needs to be removed before you start aggregating the data. It's the real noise you want to remove. You've got to be aware of what that noise is. It then goes through a cleansing process. It then goes through an enrichment process, which I will come back to. And then the business rules. Now these business rules, in its simplicity, now as I mentioned earlier, some people want those business rules to be magic. They want to be able to say something, and AI, ML, whatever it is, it's not suddenly going to do it for them. They're going to be able to look at this data and say this gets classified to this little for this reason, without any help from anyone. Unfortunately, we're not there yet. Unfortunately, you have to have training data sets, you have to have a target, you have to have a source. And when you understand the source and the target, you can find approximations or matches. You can find suitable, shall we say, joins between the two. But it's not only that, it's how you use those rules. When you create a rule around data, you need to be able to understand how it's going to be used, what its impact is going to be, and what it's going to deliver. So what you have is a series of stakeholders in that area for which the data scientist is primarily responsible. Now, a data scientist is going to spend his time understanding the data problems. He's also going to understand the expectation of the non-too technical user who simply wants the job done. Some person somewhere in the middle who just wants to get the information out of the system because he knows it's in there, because he's seen it once before, and he wants to see it again, in maybe a more aggregated way. And that is a reinforcing cycle, which allows the data to be managed by experts, by people who know the data. So I'm a category manager for a particular, I buy white goods for people more detail. As a simple example, we have a hierarchical of classification, and you go from level 1 to level 2 to level 3 to level 4, as more and more people put their knowledge in the system. Keeping that knowledge, creating a lexicon of associations between the data and its target is vital, and that is of tremendous value to a business. Ability to look at data for a particular purpose, have it aggregated from many sources. We have clients with 40, 50, 60 sources, 100 sources, some. Putting it all together and being able to run the same logic, the same rule against that data to its target is an eye-opener for many of our clients. Is a day of revelation for some of them about why didn't I know this, or are you sure, because that's quite worrying. All those good things, which are all good outcomes, can only be done through this reinforcement of the data at that point in the refinery. Once that's done, it's all ready for distribution. Everybody can have their PowerPoint, their Power BI, their Tableau, all those wonderful things. That's fine. But it's that key part, the reinforcing part, where certain technologies, up-and-coming technologies, are key, is vital to us to actually achieve our objective. Now, what is a data scientist? Coming back to that same question. Some data scientists come from a very, very technical background. They are experts in coding. They are absolutely fantastic. Some of them are statisticians, which is how it all started in data mining in the first place. It was computers aiding statistics, which started it all off. And others are, shall we say, more generalists. They understand the business, and they'd love to understand a little bit more about how it all ticks, but they don't really have the technical know-how. Now, what a data scientist is a combination of those three. And it's very important to have those three at your fingertips. If you're only good at one or two of them, you are not going to succeed truly as a data scientist. You don't necessarily have to have PhDs in all three. You just need to know the tools that can use you and the processes you need to deliver to the business the solutions, the the solutions or the answers to the questions it's asking. The terms people associate with data science quite often are many, and there's a few just popping up now. Those are kind of distractions, which is, as I was mentioning earlier, all my children say that I'm a data person. It creates noise around what a data scientist really does. These are not the important factors. They are key factors. They're not the important factors. This is not going to make you the best data scientist around. The best data scientist around is the most valuable data scientist around. He will have the biggest impact. He will understand the business. He'll know why the question was asked. He may not know the full details of the question in great detail as to the strategic vision, but he'll understand the question, and he will know very quickly if the data sets, the assets he has, can answer the question. He's not going to spend months and months looking for something that doesn't exist. He's straight away going to understand it. If you ask a very, very strong technical person to solve that problem, one, you may say exactly the same thing to that person, you may talk the same language, they will understand it completely differently to the way you said it. And I'm sure that's happened to many of us in the room when we've asked a question to somebody, and we expected this solution or this approach, we ended up with something completely different, and we think, okay, if I can see how you got there, it's a long journey, but I can see how you came to that conclusion, that's what I wanted. Because they don't fully appreciate or understand the context within which you're asking the question. So the context is very important, as is the understanding of certain amount of mathematics and statistics, as is computer science, which is always key. You need to have that skill as well. So it's a mixture, and I'd really focus, for most of us who come from a technical background, if we do, from a technical background, understanding the subject matter, and that doesn't mean being passionate about it. It doesn't mean being employed one day by a manufacturer, the next day by a pharmaceutical, the next day you just go through the motions of churning a few handles and you get an answer, you put it in Power BI and say, there you have, done. It is very much understanding the product and service your company is delivering. You should try and be passionate about it. If you are passionate about it, you'll understand it. If you understand it, you can use all these tools to help you get to the answer. Because the end game for data scientists is get to the answer. How you do it, to be honest, the business isn't too fast. As long as it's quick and it's cheap, but in reality, they're not too fast. They want you to reach the answer in the correct way that you can actually validate and back up your solution with data and facts. Most of us, and I'm on a board, so I take the blame for this as well. As I said, companies appreciate there is value. They appreciate they have big data. They appreciate they have all these key buzzwords, and now they have AI, and next door they have quantum, and they're going to come up with all these words on a regular basis to say to you, solve this using quantum, solve this using this. And you've got to be able to understand. Thank you very much for the assistance in my solving my problem, but however I'll do it my way. And you're always going to be based on what you can do, the tools you do have, and the data you have. And understanding the data you have, you can straight away kill that conversation to the board and say, we cannot even answer that question because we do not have this data set. If we were to get this data set, we could help you answer that question, but we don't. So rather than everybody wasting time trying to figure out why their big data doesn't answer their question, a data scientist will be able to quickly appreciate the feasibility of that question and maybe change the question, see it in a slightly different way, and advise the management team, the board, or whoever, to approach it in a different way which is more feasible. Otherwise you end up with somebody very, very skilled in writing code for something that's totally impossible. You've always saved all this time, people get the solution, the old trough of the solution, right? You end up in a bit of a problem. So, a successful data scientist, and also a trusted consultant, I was toying with the idea. Is it really, do people, consultants sometimes, not the most endearing title for other people, but the idea being is, you've got the technical excellence, we understand it. We understand you guys know the technology you're going to be using. You know how it's going to solve the problem. As I mentioned, passion for business is for me key. If somebody works in my business that doesn't like data analytics, which is my passion, I can't see him going very far very quickly. He can be very useful, but he's not going to rise to the top. He's not going to be a trusted consultant, somebody I can talk to and discuss things with, because I know that in his heart he's not passionate about what I do. A deep understanding of the business problem. Now, I'm not expecting everybody to go off and do an MBA, come back with some fantastic idea about how they can reshape the business and have a new strategy. You need to understand enough about the stakeholders of the business. So not only the people on the board, but the employees. You need to understand about the environment. You need to understand the world you're living in. You need to understand what's feasible, what the resource budget is, what time frame you have. And all those things put together with an understanding of the business problem in its proper context will help you reach a useful solution. Trust with decision makers. This is something which people overlook quite often. You turn up, you now understand the problem, you've got the technology right, let me get at it. I'm just about to rush off and I'm just about to get my laptop open and I'm going to solve this problem in a matter of days. In reality, spend a lot of time understanding who is going to benefit in the organisation from the question or the problem that's being asked. You're being asked to optimise a particular part of the organisation. Go to the part of the organisation, talk to the people who are about to benefit from your wonderful insights that you're going to discover in a few weeks or months' time, and find out how they really understand the problem. Find out what's going to really help them. It should align with what the management team have said, but just confirm and check with them. Is this going to impact you the way I think, and the way the board thinks, and the way the management thinks? Or how do you see the problem being solved? It's very important to win their trust. Not only at the level of the stakeholder on the ground, but also all the way up the management team, because at some point you will go off, spend a month doing something, realise on the last day before your presentation, or maybe not on the last day before your presentation, but quite soon you'll check your work, you'll check your numbers, you'll check your output, and you'll go, it's complete utter rubbish, it doesn't hold up. I had this idea in my head that it was actually making sense, and now I looked at it again. It is pretty much useless. You're going to need the trust and the goodwill of those people when you go back and say, give me another month. I'm sorry, I didn't quite, it was a bit of a long shot, I thought I could do it, I now realise what our problem is, I've got to go back and do it again. The number of projects that nearly get to fruition and suddenly add another month, 2 months, 6 months time is nearly the norm. People suddenly realise when they're about to present this, when they're about to reach the final conclusion that the whole basis for their work is flawed, and they may need to go back and review it. And again, the idea of agile development and agile working helps with that. But you've got to understand that can happen, and you've got to work with the people around you to make sure that you get their trust and empathy as and when things go slightly pear-shaped. Again, explain the results in a simple way, that's obvious. You're going to go back to the management team. Do not give them some incredibly complicated algorithm as to how you reach that wonderful conclusion which is going to save the company 5% of its turnover because you're a genius. And no. Charts, Power BI, Tableau, dashboards, objects, graphs, anything simple. They need to understand it in their own context. Do not assume they're going to understand what you're going to be saying. They will only understand what's their amount of technology. Now don't make it dumb, don't make it under 5, but I'm just saying, be prepared to get a little bit out of your own mindset, take a step back, and think, how will I present this to somebody who's not conversant with everything that I've learned, who doesn't even know the data, who doesn't understand the techniques I've used, who doesn't understand the potential, but will understand the result, they'll understand the benefit, but they may not understand the process. So you do have to have the ability to simplify your work. And of course, it was a little bit what I said earlier, addressing concerns, the people on the ground, people are going to be impacted by this, make sure they understand what's coming. Do not necessarily tell them initially what is coming, but make sure you understand that they understand that there's trust between you two and you've taken their ideas into consideration when developing the solution. Because your efficiency of a process may take 20 people out of a job immediately, because suddenly someone's realized we can do the will stuff. Your work, the whole idea of you being asked questions to make something more efficient, you going away, finding the data, analysing the data, maybe finding a new logistical route for delivery services, using some clever mapping logic or some clever algorithm is fantastic, except you've now got 20 people who need to be redeployed elsewhere. You've got to understand the consequences of the work you're doing, just to make sure it's put into context. And when you explain it in this simple way, you have to also add the knock-on effect of what you discovered or what you found. So, taking us now to the human factor, this is, again, the reason why we're here, data scientists. Yes, all those words underneath, you can all read them, they're there. The key one for me is curiosity. If you're curious as a data scientist, you'll become creative. You'll find, why does it work that way? Why doesn't it work this way? Why are they doing it that way? What is this data there? Why is this data so bad? Why is data so good? I mean, normally it's why is data so bad, I'll be honest with you. I've looked at some data sets, again, the last few days, and I'm just wondering, again, from some incredibly significant companies, and they've provided some data, and you're looking at it and you say, yes, the data is all accurate, it's there, but it's not elegant. It's not in a form which makes it easy to talk to, easy to communicate with. And that is again, one of the tools that a data scientist needs is the ability to look at the problem in a slightly different way, and to maybe address, and always take a step back before you rush in, and try and understand the problem from its different angles, from its different context. Communication, yes, that is vital in every aspect of a data scientist. I mean, you've got to communicate with the person who's setting you the problem, the task in the first place. Just hearing what they're saying is a waste of time. Understanding what they're saying may take a lot longer. So even though you may go to a meeting, it's a half-hour meeting, and someone says to you, right, we need to solve this problem, we're going to optimize this part of our business, we're going to do this, do the other, go away and find me the reasons why I'm going to make this fact-based decision, tell me about it. If you don't understand the way he's communicated, and he doesn't trust that you understood him, you're not going to get up to a very good start. And that's just the beginning. That's just you doing the simple stuff, which is the English bit. Then you've got to go and talk to all the scientists. You've got to go and talk to the database engineers. You've got to go and talk to the software engineers. You've got to go and talk to a whole lot of other people who are specialists in certain aspects, which you may need throughout that process. You've got to convey that same message, that same problem to solve throughout this process. And if you don't, you'll end up with, again, a disaster on your hand that sounded accurate, but was completely wrong from its inception. And what I'm saying there as well is talking to the data. I don't know if that makes sense to you, but when I look at data in its forms, I can look at tables and I can look at data sets and I can look at things, and they talk to you is probably wrong, but you can converse with them. You can look at them and you can look at the data and you can say, yes, I know your quality's got a problem. I know you're not going to have that bit on it. And I know that actually on a scale of 1 to 10, you're a 5 and you have to do a lot of work on you, so I might leave you behind for now. I'll come back to you. And then you start to play with this data, you start to move the data around, and you start to find which key points make sense. If you're just looking at it dispassionately, if you look at data as data and go, yeah, I'll press the button, turn the handle, see what comes out, I'm good, I'm a data scientist, you're missing the point. If you talk to data, if you look at data, and you, I don't know, smile when you look at a large sheet, and it looks very organized. A bit like when network engineers look at the back of a rack and you see lovely cabling, lovely colors, which means something. For them, it's just a dream. For data scientists looking at data which comes in an elegant way, you can see the elegance in the data, even though it may not be totally visible, is very important. So when I'm looking at the problem, and I'm trying to understand the problem, I just put this up because I picked it up. It was a very good slide I found because it simplified the whole process of what we do. As I mentioned, you've got to understand the problem. And if you don't understand the problem, stop. Don't continue. Don't go and say, I'll try and knock something up and maybe the problem will come to me later on. If you genuinely don't understand the problem, and not only state it to you, but stating it back to the person that stated it to you, if you can exchange that communication about the problem and you both agree, you both understand the problem, or the room understands the problem, you're in a good place. You're understanding what's going to happen. The way you structure the problem is going to be key. This is again what I was talking about. When you look at data, you talk to data, you look at your assets, you look at your tools, you look at your team, and you start to draft a plan of how you're going to approach this. Again, slow is fast in a sense. Just take your time, have a look at it, understand the data you need, understand the data you don't. Take only a subset of data if you can that's representative of the data set and start working on it. Have ideas, exchange those ideas with other people, and really try and knock this whole thing about until you find the right structure that you know is going to be solid and is going to be able to cope not only with your sample set, because that always works, say on Excel, you can do 100,000 rows in Excel and you're very happy. Suddenly someone gives you 100 million, you're in a bit of a problem, especially with your VLOOKUPs, as I mentioned earlier, or whatever it is. You're going to have a real nightmare. So understand what the problem is, understand how to structure a solution which can then be ported to Azure SQL, Azure Spark, whatever it may be you wish to use. Solving the problem should be logically, it should be, having understood the problem, having structured it correctly, solving it is the really fun part in a sense, because you've got all the framework to do it. So this is the bit where you're going to be doing a lot of exercising, exploratory work in understanding what is the outcome, what could the range of outcomes be, from 0 to 100, from 1 to 1,000, from whatever it may be. From totally unfeasible because it will take longer than the others has been around to solve this problem, or it's too easy to think about it. You will be going through different stages of solution, of resolving the problem. as you see it come up. And as the answer comes back to you, you may then go back round and maybe even at that point go back to the person initially and talk about the problem again and say, I now understand you cannot solve that problem. The way you described it, the way I understand it, the way both of you understand it, cannot be solved in this way. So what should we do? Let's change it, let's go back again. So there is that idea of solving the problem that way. Selling the solution, that's the key bit. It's a bit like quite often I present things in Power BI or ClickSense, and like everybody loves it. It's a map of the world. It's got dots on it, it's got geocoding, it's got charts coming up, it's got scatter graphs that are dynamic. It's people buy this. This is what all the hard work we spent getting to that point is completely ignored. There's no understanding of that. They did some work to back. Look at this map of the world. Spirit, I can change it, I can do things, I can click on things, I can go straight to Japan, I can look at all Japan, I can go straight to Germany and understand all the villages in Germany. All that information needs to be simply sold in a very, broad, in a sexy way, that's probably the wrong word nowadays, in an appetizing way. The client needs to understand what you're saying and needs to be able to say, I like what you're doing, I understand what you've done, and it appeals to me, and I do like the way that you've solved that problem. But it does take all the work around this particular quad, if you want. You must do the work properly, you must understand it. Now the impact is the key thing, because in the end of the day, you've done all the work, you've got a presentation, and it's minimal impact to the business. Well, you just wasted a bit of time and money, you've had a lot of fun, but you've had absolutely no benefit to the business. So when I look at the impact, I suppose previously, and I was guilty of this as an ex-person, I used to fundamentally look at the profitability of the business side. I was only interested in, like, does it revenue, cost saving, stakeholder, shareholder. That's what I care about. I own a business, that's my bread and butter. If I upset everyone who owns shares in my business, I may have a tough time. Those are my focus. In reality, today, that is just one of the bottom line items you need to look at. There is a quote, some good research on the triple bottom line, which is people, planet, profit. I've added protection myself because I'm a bit of I like security. I find that very, again, fascinating. The people side, what I'm thinking about on that one is principally the impact of, if you want the common good, the stakeholders, not the shareholders. Who will benefit? Who will be impacted by the work you're doing? How's it going to be delivered? How's it going to be seen? How's it going to be felt? What's going to be the impact on working conditions, fairness? All those things which today, luckily, are far more valuable than they used to be. Work-life balance, working conditions, etc. So on the people side, understand when you deliver a solution, an insight, what is going to be the impact on those that are receiving it, not only in your company, but they all have families. So when you have one employee, you actually have 5. You have that person plus their families. Let's assume there's 4 or 5 people in their family. There's a much wider number of people you're impacting in everything you do. On the planet side, we are now bound, and every company has an awareness. I think every company has an awareness, I hope every company has a good awareness of its ecological footprint, the product life cycle, where it gets its goods from. We work with clients who are concerned about the problems of certain rare minerals, rare earths, rare metals, and they have to go through certain types of refineries, or they have to be used by certain middlemen that were certified themselves. So make sure that when your solution comes out, you've taken that into consideration. Reducing waste is key. My favourite one, used to be my favourite, but it's still the one I worry about most in my business, as a business owner, is, are we hitting the numbers? Are the revenues coming in? Are my shareholders happy? Have I controlled my costs? And if I'm very excited, I want to do P&L analysis and balance sheet immediately go down, I can get very excited about that as well. But I do realise that profit is dependent on the other two, the people and the planet. You can lose your name very quickly and lose your business completely if you don't take care of the other two. It's not asking you to take care as you're the owner of the business, you do it. I'm saying the work you're doing, the impact you're going to have, you have to put that in your presentation. When you present back your solution, it's not just, this is the answer, there you go, well done. Or here's 3 options, 2 of them are mad, one's a good deal, choose a good one. I've done my job as a consultant just to tell you what to do. You've got to understand also, you've got to articulate the impact on the people, you've got to impact it on the planet and on profitability. But now, again, more importantly, and we saw this daily, I'd say, we see the impact of not listening or not paying enough attention to protection. And what I mean by protection, it had a P in it, so label for with a P, which is a good thing. But what I thought was security, data security. You've got to understand not only the security of your data as I'm the company, I have data, I must be secure. The confidentiality of that data when you're using sensitive information from various people in the population. If you don't take that into consideration, again, in your solution, it may be the best solution in the world. If it breaches GDPR, no one's going to touch it with a barge pole. If it doesn't, if it has a problem with poor cryptography or poor security or poor transfer of data, it's never going to fly because the confidentiality will be breached. Are your team that when you deploy or when you provide this insight, have you thought about the training required for people to use your product? How are they going to use it? How are they going to make sure that they keep, you develop a new piece of software, you develop a new approach, a new process, a new workflow. How are you going to make sure everyone follows the line correctly? How are you going to make sure they do the right thing at the right time, the right way? Has that been thought of? It's not your job necessarily to do it, but it's a consideration you must put to the solution to make sure it's a holistic solution, that the solution has been looked at from many angles. What we are seeing quite often to specialize in is purely the solution. Here's a problem, you go and do data and you find the solution, come back and tell about it. When you come back and tell about it, do mention on the company itself and profitability. So the key takeaway from this is probably these 4 items for every solution, but it's also the impact it's going to, the impact it's going to deliver to the business itself. If your idea is fantastically sound, the data is brilliant, your presentation was absolutely fantastic, everybody understood it, but the impact is negligible, you just, again, wasted everybody's time with a pretty presentation. So understand the weight of the impact, understand the consequences of the impact, and keep looking for that impact. When you're doing that problem solving, as I mentioned earlier, when you're solving that problem, think, what impact will this have? Not only on a positive, negative way, in a meaningful way to the business. Is this going to change the way we do business? Is this going to have a minor impact? It's going to change the way we process that particular piece of work. If you're a bank, we're going to process mortgages in a slightly different way because we found a new way, using data algorithms to do it a slightly better way with the information we have on our clients. Fine, good. But you've got to understand the impact of it on the people, on the users, and also on the business. So as long as you keep the business aspect in your mind, as long as you keep the concept of that it is all about it's about the business, but the business is a much wider thing than it used to be. What you've got to keep in mind is what are they asking for? Why are they asking for it? Do I fully understand it? Am I going to give them a solution which holds water from many, many angles? And is that solution going to be cost effective? Am I going to be able to do it in the right timeline? And does it have legs? Is it going to last a while, or am I just coming up with another solution that will simply vanish in a few months' time because someone has to come up with another better idea in the middle or whatever? Make sure your solution, your idea, is well-grounded, it's fact-based, and can be challenged. Make sure you like being challenged when you come up with an idea. Appreciate the challenges people will have about your idea, and make sure your insights are delivered in a very, shall we say, digestible way. So that, I think, is my quick round trip of data science, data analytics, and I hope you were able to take something away from that. And thank you very much for your time.
We've got time for some questions with you, so the floor's yours. So stick your hand up if you've got a question. Okay, all right, hey, go on.
You mentioned it a few times about the relationship between the data skills or the technical skills and understanding the business and being able to see that context. Does that mean that inevitably, as people develop their careers, they have to focus on a particular sector? Or
No, I think I mentioned the idea of the passion about a particular product or service. That could be you can become passionate in your work. If you believe in the fact, you believe in what you're doing, you see the vision, and you can become passionate. It doesn't mean people want to go to the college, you can be passionate about it. But also on the skill set, depending on the size of the company, you'll either have to because they'll be big enough to have nearly every single type of solution out there. A lot of companies buy one of everything, just in case. You'll be able to leverage that. I mean, you'll have your pet tools that you have to use which work well for you, the way you're thinking, the way you're developing. But the key thing is not so much the vertical. It's a lot of the data we use, a lot of the things we do can be spread across several verticals, depending on the level of good answer to the data. But it's understanding why they're asking you to solve that problem, and how passionate can you be about that particular solution or that particular input. So it's not very specific.
Almost like a methodology or an approach.
Yes, it's each of us will have our own approach to solving a problem. We'll try and learn from each other. We'll try and gather the best information we can. I mean, I spend my time learning from others about how not to make the mistake we keep making, which is experience. When you keep messing up, and then you find out not to do that way again. I keep learning all the time. It is important to make sure you expand your horizon somewhat. Otherwise, you get used to the way you do things, and it's kind of everything. The guy with the hammer, everything looks like a nail. This is the way you're going to approach it, and you're going to smack them all the same way at the same time. It's really a case of understanding what you can do the way you want to do it, and then leveraging what's around you. Some companies will have 20, 30 people around you to help you. Other companies, you and two guys sat in the pod somewhere with lots of coffee. It varies, but it's learning is a kind of continuous thing that you'll have to do all the time, especially with all the stuff with emerging technologies coming out. It's going to be hitting you anyway all the time.
Questions? So I've got one for you. Think about all the skills you talked about. Quite a few of them you could describe as introverted skills, so understanding analytic tools, science of the data, getting right into the detail, but also quite a few extroverted things where you actually have to communicate, you have to ask questions, understand the
Yes.
etc. What order would you recommend people follow? What are your thoughts on how people might
It depends where you come from. If you're already a very technical person and you've got all those skills, and you don't need all those skills, you are good. You are technically good. You may not. Some people that are mentors, they're technically excellent, are challenged when it comes to communicating with others, and do have an element of hesitancy in opening a conversation, or disagreeing with the boss, or arguing with the boss. Not arguing in the sense, the negative sense, but arguing, conversing, exchanging ideas. And they just won't do it. They'll just say yes and go away, and hope they understood it, and try and build something they hope is what was asked of them. So there's a development of the ability to communicate is key for several reasons. One, for receiving the information you're going to be given. Two, for talking to people around you. You mentioned learning a second ago. If you don't communicate well with those around you, and you're not an engaging person, no one's going to talk to you. You're not going to learn very much at all. But also the ability to communicate your idea or your insight once you've found it. Once you've developed your idea, your impactful analysis. If you can't really, wow them, if you can't really get them thinking, actually this is quite useful, I can see where it's coming from, I can see how this is going to work, and you've led them up that path because they won't do it themselves. You've got all the facts, you've got the information, you've got the presentation. You're going to have to guide those people through. It's not a one-stop shop. You don't just do it once and that's it, I've done the presentation and go away now. It's probably going to take you months to convince various part of the organisation the value of the work that you've just done. So you do need to be able to communicate. If you struggle, have a sidekick, have somebody with you who is your evangelist. You've got to be an evangelist as well yourself to really convey the idea, the purpose of the idea. Because most people don't like change. I know we will love change, theoretically, we will love a new thing, we love something gadget, but actually in the business context, most people don't like change. And they do push back a little bit against it initially, but if it's well presented and it's fact-based, and there is a reason why it's going to improve our life generally, people will buy in over a period of time.
That's the question towards back there.
Yeah, that was me. So you mentioned sort of people sort of coming up with these sort of future tech ideas and being like, oh, I just want to apply this to data, which is something that I run into quite a lot. And I just sort of wanted to get your advice on how you deal with that, because the constant idea, for at least the company I work at, is they'll just be like, we'll just put it all together and then we'll add some stuff to it and then it'll all be magical. And it's just sort of, that's not the reality, but trying to let people down without saying, well, we can't do nothing, but we also can't do everything.
I have we share the same. I had a company last year, and they had a very similar thing. They said, right, you guys do data. Here's my data. I want some AI and ML to solve I'll think of the problem in a little bit. I want to be the first in my industry to have AI ML throughout my business in this particular sector. What do they say? Do you want to do with it? Oh, no, don't mind. Just give me AI ML, and we'll do lots of things with it. And there's this kind of, obviously technically it's possible, but you've got to be able to articulate what you want. And quite often, people will articulate what they want. I wouldn't say that's probably wrong. We've seen it on TV, or having heard it from the marketing team, or the sales team, of the products, all the several products. And as you say, they'll put them all together, and if I use that bit from there, and think about it, that bit from Amazon, that bit from Azure, and this bit from somewhere else, they'll put it all together in one place, and best of both worlds. Yeah, it'd be fantastic, it would be great. The technical challenge of doing that, the amount of resources they've got to spend, the time they've got, and the fact they don't quite understand they're actually at the cutting edge of something which isn't yet being developed, can be a challenge. Now, to communicate with them, what I found initially, again, from experience, having done the wrong thing, and doing the right thing later, I hope, is initially I said, let me go away and I'll think about it, and I'll come back to you. Thinking, how do I convey that idea to them? How do I politely say no? Because it's business. The guy's very keen. I know technique can be done. I can get the experts in. Maybe we can achieve something. Maybe it's, you say, better than nothing. What I do now is quite, I suppose, quickly, is assess exactly what it is they want. If they can't articulate it, there's no solution. So then you can come to me with, I want something blue. It means nothing to me. If they can't articulate it, then you just have to drop it and come back when they can articulate it. If they have articulated very well, but you know most of it is smoke and mirrors, vaporware, and really in reality it's not that solid, or it may work for a small set, but not for this set, or the cost of it would just be too great. Tell them straight away. Push it back straight away and say, right, I can see these two parts being right. These are completely wrong. They'll never work together, and you will simply waste time, waste money, waste resources. However, let me just do those two bits that I know will work together. Once we build those two bits, we'll then go and look at the third one and build slowly in a kind of sequential way, and I know the temptation is to say yes, we can do it, but in reality don't, because you know what happens in the end. But I'm sure if you've experienced it, you know the outcome. It's not pretty.
Two-part question really. So when you're performing this analysis for companies, invariably I imagine that not every idea turns into benefit and value. So what are the sort of success rate do you see? And the second part is, what advice do you give to make sure that the data science budget isn't the first budget that gets a red line put through it in a company's cost?
Okay, second question first. If the company kills its ability or its desire or its curiosity to understand its own data, I think it's got other problems. I mean, that's the symptom. That's just, if that's what you're going to cut the funding from now, what on earth are you going to be doing next? You know, there's not much. It's so fundamental to the business. It'd be strange to find. I mean, of course, there are businesses that require absolutely no or very little data. If I'm buying and selling antiques, I probably don't need to have anything sophisticated to store my data or to analyze it. However, the vast majority of companies today depend on the data they have about their clients, about their turnover, about their business, about the world, about the risks, about God knows what. I mean, it's so anybody cutting their budget back too far on data, they're either having a moment of, shall we say, a come to Jesus moment about the financials, which is fine, that happens. Or they miss the value of data, and it's up to us to convince them or to speak on behalf of the value of data, because we probably haven't done our job properly if they think that there's no value in data. There is. The first part of it, I carried over with that. And the first part of the question, success rates. What's the question? And I'll tell you the kind of success rate. I mean, the questions which require a bit like the lady behind you. The questions that require known, complicated but known processes or known approaches, known structures to deliver them, you can quantify those as how successful they're going to be, and you should straight away say, I understand you want to reach that far. You'll actually only be able to reach 70% of what we're going for, because don't even try and go beyond that. You're going to waste your time and resources. It's the opportunity cost of doing it. You're not going to like it, so don't go there. So you tell them quite quickly what can be done. There are projects which are test projects, research projects. If you have the budget for those, that's great, because in a sense, you're expected to deliver something at some point in time. But most if you structure, if at the point of structuring the problem you understand it can't be done, stop there. It's similar to agile development. If you're writing code and you suddenly realise, actually we're going nowhere with this, this is just a dead end, it's not going to happen, you just suddenly realise it's just exponentially wrong what we're doing. Stop. Tell the client, tell the person, rebase and start again. If we carry on to the point where, as we've seen and we see in the press, and there are even some very large organisations, some private, some public, who go down a path of immense time, suddenly discover that the whole thing was flawed before they even started, but no one told them. No one wins that. I mean, it's just a complete waste of time. So I think the success rate, you should be able to predict a fairly good success rate to a point within a bracket of success. So in other words, you might be 70-80% successful. That's your success criteria. If your aim is 100%, you'll probably fail 99% of the time. If your aim is, I'm going to do 80%, you'll probably be successful the vast majority of the time in a project. But it's also stopping and saying, I'm going to change the direction of this project, because otherwise I will not deliver to you what you expect. So I think it's managing the project rather than just having one thing and going off and doing it and hoping it works. There's a lot of management involved, a lot of tweaking. This.
I'm not a data scientist, but I use a lot of data, and I understand how you guys get to your endpoint and all the businesses. I find more the problem is, as you say, in your pyramid further down, is we have legacy systems which can't actually generate the data we want, and there's a lot of patching going on, and so I think to be, as you're saying, to be successful as a scientist, it's you have to build upon foundations. And that sometimes is a hard sell because regulations might drive a certain amount of data, and a lot of it is done manually, it's not automated, which is part of the problem, I think, and it kind of slows you down as a data scientist, I would have thought, in terms of your effectiveness.
The collection of data is key. I mean, my work, my challenge is when I come across a project, the first thing I spend my time on, everybody, not everybody, but a lot of other people are looking at what it's going to look like in the end, which is fantastic, is where is the data, what's it stored in, what schema am I going to build to receive that data, and how am I then going to interrogate that schema once it's in there. Everything else will come naturally. And if you get that collection phase wrong, you might as well stop the rest of the pyramid, you might as well take it away, it's a waste of time. So again, it's that initial phase of how you're going to structure the solution to the problem. It's understand the collection phase. Now, I have clients with over 100 sources of data, some very complicated, some very simple, but they all uniquely need a method of communicating to me. Some with 10-minute refreshes, some other systems with monthly refreshes, some weekly, some quarterly, it doesn't really matter. As long as your communication channel is clear, will map to your schema from which you can do your analysis, you'll find. But do spend the time on the collection. And that's, since it's a small company, when I started, you do everything, so you learn the hard way. In larger companies, you will have engineers who will be specialists in those areas. But you need, as a data scientist, to be confident they know what they're doing. And if someone says to you simply, I'm just going to put talent in, I'm going to put point there, press the button, it's all going to come. Somebody says, well, out of the box, I've been disappointed with this. You need somebody who understands how to use that tool. Or someone says, I've really got the data for you. Lucky you asked. I've actually done it last week for somebody else. It's already done. You know, just press this button, it'll come to you. And you look at it, and it's a complete waste of time. You need to articulate the data points you need to solve that problem, and make sure those data points are being brought in by the collection team. If you get that right, everything else builds nicely. It's the exact example of the pyramid. If you get that base layer wrong, forget it. It doesn't matter what you do afterwards. No one's interested because it just won't hold water. You can give them the most beautiful presentation with the wrong data, you may be able to sell it. But you know deep down, the data's flawed, and you, in your heart of hearts, will just put your hand up and go, let's go back again and do it again. The amount of problems I've had collecting data are, my life has been collecting data in the right, trying to collect it in the right way, and then looking at it and understanding its maturity and understanding what to do with it. But it is key, absolutely.
Now, in your experience, what proportion of the solution ends up being a true AI machine learning solution rather than just swapping out data, some data or some analytics, change products, and a full machine learning solution?
The question that was asked of you is, does it need AI now? Does it need those tools to be the answer. If it does, great, okay. How far can you use them? How far are you confident that the tool is going to be effective? Because you can get some fantastic AI tools and ML tools. Are they genuinely adding real value? Or are you simply implementing them because someone said I want that in there? So you've got to understand that. I find I have a little bit of a, maybe a little bit of a, I've experienced too many things going wrong. Just presume that simply because I put something in there and it's meant to do what it does, that it will do it in the end. What I've found is that you need to train the data, you need to set the data, you need to test the data, you test it, and you retest it, you retest it, you tweak the weightings to the, to the blue in the face, and you still don't get the answer right, but it's better than it was. And you come to a point where you're good enough. It works, it's going to deliver. It's not perfect, it'll never be perfect, and I know that. So what I can do, it can deliver. So I was working recently to try and, there was it's not a big list, it was 500,000 entities, trying to find a correlation in those 500,000 entities with no trained data sets. So doing unsupervised learning across the complete set to try and find commonalities. Obviously for commonalities in the word, but it's then to go to Azure services, finding which ones are entities, which ones are people, which ones are not, which ones are don'ts, which ones are whatever they may be, grouping them all together, clustering them, then finding relationships with them, then digging in other data sets to try and find, and all that had to be done in a repeatable way. Therefore, I had to use a lot of AI and ML to actually do that to get the answer. But that's taken months to do something as if you had a person to do it, they'd understand how to do it, they'd look at it and they'd be able to do it, except they can't do it for 500,000. They can do it for 5 or 50 or 500, but they can't do it. And then if I put 5 million in them, they'll never do it. So we use the tools to their abilities, and quite often I will not use some of the tools which I think are great names and people want to buy them because they're not going to add the value, the supposed value, for two reasons. And I'll be first in it. I may not be my team may not be fully conversant with the capabilities of that tool because it's quite new. It's probably documentation and training is maybe not there yet. Potentially it could do the work. So it's a question of the tool itself, your ability to use it, but also is it the right tool for that solution? As I said to you earlier, clients ask me for AI, and ask me for ML. Yeah. But in reality, what they want is a solution. They just think they want that in there because everybody else has it. So I'm
interested in how many actually become real ML solutions.
Real? What's a real AI?
Actually implement a real machine learning solution. I mean, you can play with ML and
yeah.
you can get your data.
But you're starting with data. So you're starting with raw data. You're starting with some fundamental input, which is not AI. So your base layer, we talk about the pyramid, your base layer is pure data. You're then going to build data engineers who will then do a certain amount of work at that point and start getting data ready. Then you're going to start using your AI ML at the understanding of the data. So your 3 first layers are not AI ML, they're good old-fashioned gathering data, preparing data, physically getting it ready for AI and other things. And then you're going to have, and even if you go further up the top of the pyramid where you have deep learning and other things, you can start going mad on that one as well. But it's all built on very solid foundations. There's very little, unless you have a widget or it's something which it's a pure app which just goes and collects data from social media and does some clever thing with it. It's an app in its own right, but if you're doing bulk data analysis, if you're solving large-scale problems, you will use parts of AI, you will use many other tools, but your fundamentals will still be this building block. I wish it wasn't, but it still is good old-fashioned getting the data in the right place, putting it in the right place, and then getting ready to apply information to it. It's a bit like a Power BI with your ClickSense. You have to do the donkey work to make it look nice.
I think we're sort of guys right out of time. We've probably got time for 1 or 2 questions. I think Ian, you've got one hand up here.
Yes. Is there like would you say there's any kind of real difference between data analysts and data scientists?
Yes, there is. Depends who you talk to. For me, a data analyst is deeper in the data structure, in the data. Let's say for me, he's on that cusp of data engineer. He's got a bit of a software, but not quite. He's a data engineer and a data scientist. He's not necessarily totally attuned with the problem. He knows part of the problem he wants to solve. He'll assist the data scientist. He'll work very closely. He's the kind of expert, one level removed maybe from the problem, from the business problem. He's the analyst. He's going to be far deeper in the analysis of it than in And this is why data science is a kind of funny term, because in reality, you've got to always remember why you're doing it. You can give an analyst a task and they'll go off and do their task. Why are you doing it? I was told to go do something like that. So, and they are used interchangeably as well. So people call data analyst, data science the same thing. But to me, the analyst is somebody I go to for a specific type of set of data that I know this analyst is really good at using the certain tools with. Not necessarily something I would do. And I would task him to do a certain part of that project. A more detailed in depth. But as I said, they can be used interchangeably. So it's just my view.
Okay, last question.
Okay. Let's say you've built a pyramid, the data scientist has come up with a fantastically useful, relevant, and most importantly, a valuable solution. How much should the data scientist be concerned with the ability for an organization to adopt that solution? So things like management of change, sustainability. How was your experience of that?
The way you introduce it is very key. If you present them back, this is a real solution. But you believe you've just found something absolutely fantastic. You've found something of great value. You've just done the math and you've seen that actually this will save this, that, and the other. It can improve whatever. If you just dump it on the desk or present it in a way, people, the shock of it will be too dramatic. If you present it as part of a story or a strategy, as part of building into that strategy, now you may take one of the senior guys aside and say, "This is a bit of lead balloon here, but we need to break it up into smaller chunks for it to be digestible for business." Then that's fine. I think if you have that solution, no one's going to stop you delivering it if it's done in the correct way, in the correct, shall we say, sequential way. Because sometimes you're right, the solution can be too dramatic. It is move our operations from day to day. It is change the way we've been doing this for 30 years and it's been working really well. Look at our numbers. But your solution could actually multiply those by 1.5, 1.2, which is very meaningful. There is a risk, because there's a risk of change, as I mentioned. People don't necessarily adopt that, love change. But you can do it in a way which is sympathetic to the audience. And that's again going back to the people side. Understand the audience. Not just the audience who are going to be hit by it, but understand those who are going to be affected by it, those who are hit by it. And also try and think of other ways you can deploy their skills, or retrain them, or use them in different ways, or maybe they need to just be retrained in this new way of doing things, and then people stay in the same place. It doesn't always necessarily need to be a negative thing. You can be learning. Sometimes what we've done, we've implemented solutions where there's been a lot of learning required for people to rise up to the next level of engagement with the technology, and people have just gone, "No, it's not me. I'm just out of it. I'm just not a tech. I can't." And they time in their life, whatever. So you may have that impact as well. But I think if you do it in a gentle, I think, in a way which they're able to digest it, they're able to take it on board as improvement, as success, as the next best thing, as they're going to be more valuable because they've got some training, and they're going to be able to adopt your tool or your solution or your idea, then that's fine. I think if you just dump it on the table and say, "This is a great one, look, 1.2, let's do it." If it's that big a solution, it's got that much potential, gently. And somebody else will know the full solution, but just as you present it gently to various teams. Otherwise, the impact may be too great. You don't impact. Don't blow the doors.
Okay, that's great. So just join me in thanking Hugh. So yeah, if you want to stop around, there's some wine crisps outside. So.